Hey guys, welcome back to another Zhan IGCSE biology video. So today will be chapter 5, which is enzymes. Okay, so first thing about enzymes, they are all linked into catalysts. Or we also can be called as biological catalysts. So a catalyst is a substance that increases the rate of a chemical reaction and is not changed by the reaction itself. Okay, and therefore enzymes, it's what it's made of proteins, which is to function as a biological catalyst. Okay, so remember that catalyst only speeds up a reaction, but it remains chemically unchanged at the end of the reaction. Okay, so this is what you have to know. Okay, so for this diagram, we can see that the reactants are always start at kind of like the first starting point like that. Then it rises activation energy without enzyme and activation energy with enzyme. And therefore, after that, it goes the slope down to form you the product. Okay, so it speeds up and then it eventually slows down. Okay, so there are different enzymes. Okay, this is where we link back to chapter 4 of biological molecules. Okay, so give one example like starch. The amylase is the enzyme to break down starch into maltose. Okay, and therefore protein, the enzyme to break up protein is protease. Therefore it gives you amino acids. And lipids, or what we call as fats and oils, they are all break down by the enzyme lipase to form you fatty acid plus glycerol. Remember this, do not put fatty acid only, therefore it gives you the whole thing wrong. Okay, and lastly, this is you don't really need to know, where hydrogen peroxide requires the enzyme catalase into water plus oxygen. Okay. Okay, this is a diagram where you have to understand how the enzyme and substrate works, and if therefore they form you the product. Okay, so first thing, we always must have an enzyme because that is the basically your lock and key model. So every time the enzyme, there is always a shape where it's called the active site, where it allows the substrate, the one that keys and binds into the lock together to form you a perfect shape. Doesn't have to be a perfect like a square, but as long it fits to the active site holes it has. And after that, it has formed into an enzyme substrate complex. You can see from the second diagram where the substrates are stuck, joined together in the active site. After that, the active site helps to make the substrate to form the product after it has been mixed with the enzyme. So the enzyme is still remains as the enzyme, therefore it gives you a product. Okay. Next one. An active site is basically a region on an enzyme that binds to a substrate to doing a reaction and therefore to make a reaction. So it always have a particular shape in order it can form together to build a complex. Alright, so example, it gives you a square shape in the enzyme. Therefore, you must find a substrate which has the same square shape that it can bind together. That is what you call it as an enzyme substrate complex. Okay, the properties of enzymes. So first thing, all enzymes are proteins. Remember this because in multiple choice question they always love to ask whether what are enzymes made of. So the first thing is proteins. And secondly, enzymes are catalysts. Okay, not biological catalysts. They also can be called as that also, but usually it's the first form when you cannot find your answer, it's always catalyst. And then enzymes are specific. What I mean by specific is through the substrate, that it can only connect with the substrate. It has the same shape as the enzyme. And enzyme works best at the particular temperature of pH. We can look more in that later. And enzymes can be reused again. Okay, first one is pH and enzyme activity. We know pH is the pH 1 to pH 14, therefore starting from acidic in pH 1 to pH 6, pH 7 is neutral, pH 8 to pH 14 is alkali. So many enzymes work best in neutral conditions, which is pH 7, and some prefer acidic or alkaline conditions. So its rate of reaction depends on the optimum pH, which enzyme works best at the particular pH actually. And next one, the change in pH. Whether it's too high or low, it alters the active site of the enzyme. So therefore, it gives you a different activity. Firstly, it denatures. We look more into denatures, what it means. Okay, temperature and enzyme activity. So similar as pH, every enzyme has an optimum temperature. Most of it is 37 degrees, which is our human body temperature. So if rate of reaction increases until the optimum temperature, that's where it can go up to its best. Whatever goes after 37 degrees, the activity slows down, and at 70 degrees it denatures. So what I mean by denature is that it dies, but we don't say die because it's a wrong word. So therefore the suitable word, it should be used as denatured. Okay, from this graph we can see like at 10 degrees the rate of reaction is at 1 times per minute. So therefore it goes up roughly at about 37 or 38. That is the optimum temperature, and that is how much the maximum the enzyme can go. Whatever goes after that, it drops down, the activity slows down drastically because it has crossed its optimum temperature and it denatures. Okay, so yes, from here, rate of temperature increasing from 10 to 40 degrees. So 40 degrees is the optimum temperature, means this is where the enzyme works best at this temperature. And rate of reaction increases until 40 degrees and decreases because it slows down. And rate of reaction decreases down to 0 at 60 degrees, means all enzymes denature. What it means by denature again, dies. Okay, pH here. So you can see like there are two different enzymes working two different kind of acidic or alkali conditions. Most of them, they met at nearly pH 5.3. That's where it meets. So we can see that enzyme X is suitable for acidic conditions, while enzyme Y is much of the neutral to alkali conditions. So if we want to describe the shape of the graph, we can say that enzyme X optimum pH is 2.0, therefore enzyme Y optimum pH is 8.0. And the rate of reaction increases until pH 2, where the rate of reaction decreases beyond pH 2 for enzyme X. And the rate of reaction increases until pH 8, and whatever goes after pH 8, it drops. So there are no enzymic reaction at pH 5.5, no enzyme Y reaction above pH 10 and below 4.5 because it has already slowed down and started to denature. So that is all for enzymes. So hope this is a short video and you can understand this well. So see you guys in the next video. Bye bye.